Hello class, and welcome to lesson 2.8 on solving percent problems. So first thing is I want you to copy down the important vocab at the top right here. It's also on page 155 of your textbook. Here's what we know. A proportion is an equation that shows that two ratios are equivalent. So just like in chapter 1, everything is basically about ratios. That's what everything comes down to. In a percent proportion, one ratio compares a part to the whole. The other ratio is the equivalent percent written as a fraction with a denominator of 100. That's because percent is always over 100. I set up my formula as something, and I'm going to give you that second half. Something over something equals percent over 100. Dolan, do you happen to know what it is?
I think so.
Go ahead. What do you think?
Is it, like, for example, 30 over, let's say...
Well, what were the words? Do you remember the words that I used in the video? I know, that's okay. So the words that it is, if you watch the video, it would be is over of equals percent over 100. And that sounds complicated right now, but it's going to make sense a lot, especially if you don't understand this. Watch yesterday's video. Yesterday's video was a long one with lots of pauses, explanations that you guys can do. But the formula for percent problems is over of equals percent over 100. Is over of also means, as fractions do, part over whole. But is over of is the phrasing that we typically will be using. Is over of equals percent over 100. Here's what we're seeing. How do you compare the part and the whole? So what is that word? We all know this. What is the word that we call the part of our fraction? What is the word, Vahe?
Like one of the steps.
What is it that we refer to it as? But what is the name? It is a one-word mathematical name. Do you happen to know? I'm going to give you the first letter, N, and hopefully you'll be able to tell me from there. What do we think? Does anybody know? I'll give you a hint. The whole starts with a D. So do we see what is the part?
Denominator and I forgot the...
So Vahe says the whole is denominator. And then Pearson, what is the top?
Numerator.
Yep. Perfect. So we see all these things. Denominator, numerator. Part is the numerator. Whole is the denominator. So we see that. Using the information, fill out the ratio, like using the information in the first ratio, fill out the others. So here, I have 2 to 5 or 2 to 5, right? We all agree with that so far? We see the nods. This is from chapter 1. We agree with this, right? Excellent. Now we have this. We have to figure out what goes there. I don't know what goes there. If there is a blank spot in my problem, I'm going to put an X there. And I'm going to have to figure out exactly what goes there. So I'm going to have to figure out what we do. Ben, do you have any idea what we would do in this case? Think about the fact that they are ratios. What do you think we do? What about Dolan? What do you think?
Wait.
Nope.
So, to find out what 2 equal...
We are going to treat these as a ratio table, you guys. They're ratios. Right. So exactly as Ben was saying, do I point my arrow like that, or am I going to point my arrow like that? Which way do I point my arrow? If you think I'm going to point it like this, hit go faster. If you think I'm going to point it like this, hit go slower. So what do we think? Camilla, why do you say that our arrows are going to point this direction? Can you tell me why you say that?
I say that because usually you would multiply the denominator for the first fraction.
Ooh, yeah.
Multiply a number to get the other denominator and numerator.
Yeah, so she says normally we multiply the denominator to get the other denominator or numerator. She's correct there. We can also divide if it said 1 at the bottom, so it's not necessarily fully that. But yeah, she's got it halfway down. What else do we think, Sophia? Why do we point the arrows that way, according to what you guys say?
So I actually think why we point the arrows.
Pearson, why do you say the arrows point this way?
I say the arrows point this way because I say it because we can't just add the numerator plus the denominator, and so we would have to do the denominator and put it to a... I don't know.
You guys are saying things almost exactly with what I want to hear. Do you remember what I like to call us? What do I like to call us? Remember, I want you guys to say, what do I like to call us? We're math what? We're math... What are we, Dolan? What are we, Alec? Do we know? What are we, Delaney?
Pirates.
Hold on.
Math pirates.
We are math pirates. Alec, did you have that too? Sorry, you didn't unmute. Were you going to say that too, Alec?
Yes.
Yes, Alec and Delaney said it. We are math pirates. We are math pirates, and we always point our arrow to the X. We always point our arrows to the X. So that's exactly what we do. Even if it's not multiplying, even if we're doing division, even if we had that being 200 over 500, we always point our arrow to the X. So we always point it to the X. And as you guys were saying, we have to get from the 5 to the 100 because that is exactly how we solve. These are ratios. It's exactly what we do. So based on that, how do I go from 5 to 100, Lucas?
You have to multiply 5 by 20 so you can get to 100, and then you have to multiply 2 by 20, so that way you can get 40.
Excellent, because what we do to the bottom, we do to the top. Exactly, you guys. So what we find out is that 40% of 5 is equal to 2. 40% of 5 is equal to 2. But we're going to see my is over of as it comes in later. So we're going to see that. Here's this. Kara is on her school's basketball team. She's completed 9 out of 12 free throw shots successfully. Write the ratio as a percent and as a fraction in simplest form. So first of all, what's our initial fraction? Who can tell me the initial fraction that we just have by reading that one problem? Remember, initial means first. Dolan.
9 out of 12.
Perfect. 9 out of 12. 9 over 12. 9 to 12. Any of that. But here it's easier to write them as fractions for our ratio table. Now, if we're trying to find a percent is always over what? What is the denominator for a percent? Always. What is the denominator for a percent? Always, Sophia?
A 0.
It's not a 0. Good guess. Vahe?
100.
Yes. So the denominator for a percent is always 100. So I'm going to create my little ratio table here. I'm going to make my little ratio table. Here I go. I'm splitting it in half already because I know that no matter what, it's going to be split this way. Is this going to be a single jump or a double jump? That's what I need to figure out. Is this going to be a single jump or a double jump? What do we think? What do we think about this? What do you think, Ella?
I think it's gonna be a double jump.
Why?
Because you can't get to 12 just to I don't know how to explain. Like you can't get to 12
Can I go from 12 to 100?
Yeah.
Exactly.
Yeah, you need to do 2 times.
Exactly. She's correct. The words that she was saying was, it has to be a double jump because we can't go straight from 12 to 100. That's the first thing we think about. Just like in chapter 1, we have to figure out, is it a single jump? Is it a double jump? So I know I want to get my percent over my 100. And my fraction is 9 over 12. I don't know what my percent is. It's asking me to find the percent. So I'm going to put it as an x. It's also asking me one more question that I'll get into in a second. Now, what is the greatest common factor between 12 and 100? Who can tell me the greatest common factor between 12 and 100? It's the greatest common factor. Vahe?
4.
4 is our greatest common factor. Yes. Kayla, how do I go from 12 to 4?
You divide 12 and you divide 12 by 3 and then
Exactly. I divide 12 by 3, and just like you said, we do it to the top. On your fingers, what is 9 divided into 3 groups? Yes, it's 3. Perfect. And then I have to do one more jump. 4 to 100. This one, think about money. 4 to 100. What do we think it is to get from 4 to 100? What do we think? Vahe?
Multiply by 25.
Times 25. So here we do the same to the top. Times 25. And who can tell me what we get our x equal to? Based on that, 25 times 3, what is our x equal to? What is it going to be equal to? Marley, what do you say it is?
35?
Ooh, that's really, really good. That's a great guess, but it's not 35. We got a 5. Lucas?
75.
75. We had that 5 at the end there, so at least by multiplying by 5s, we always know it ends in a 5 or a 0. But yes, we get 75. What that means is she made 75%. Am I done, though, answering this basketball question? If I read this whole thing, am I done answering the basketball question, nodding our heads yes or shaking our heads no? Am I done? No, I'm not done. I have one more part that I need to do. Who would like to tell me the last part that I need to do? Ella?
So what you're going to need to do at the top, it says fraction and then put it into simplest form. So
Oh, she got that. Yeah, fraction is simplest form. So what do?
we're going to have to make it into fraction and then simplify it.
Perfect. So we already found our initial fraction right here. And then luckily, all we have to do is simplify it. Hey, you guys, did we happen to already simplify it? Did we happen to already simplify it by doing the... Yeah, right? We see our heads nodding. We just so happened, and that's not always the case, but we just so happened to already simplify it. I cannot get any smaller than 3/4. They are not divisible by anything else. So it's 75% or 3/4. Those two mean the same thing. 75% and 3/4 mean the same thing. Okay? So remember, is over of or part over whole is going to be percent over 100. So we see this. That's what we need to know. I will tell you the best way that we're going to do it, and I'm going to have to teach you the key words, is over of. That's what you're going to be using in future math. That's what you're going to be using a lot in future math. They mean the same thing, but you might not always be able to identify the part and the whole. And I'm going to show you why, okay? So, I've got this question right here. I want to identify. My formula is over of equals percent over 100. What part of my formula never changes? What part of my formula here never changes? It is the same no matter what question is being asked, Dolan. What is it?
The 10.
That 100 at the bottom. So the 100 always stays the same. The 100 at the bottom never changes. So that is always there. We always have is over of equals percent over 100. We might not know what this number is going to be. We might not know what that number is going to be. We might not know what that number is going to be. But this number will always be here. Now you see why I broke this problem down. Now you see why I wrote the is over of equals percent over 100. We need to be able to break this problem up even more. And we need to figure out what goes where. We need to figure out what goes where. So the first thing is we have to identify each part of our answer. You have to identify each part of our answer. So let's identify what our is, of, and percent are. What our is, of, and percent are. Who can tell me what they think the is? What is our is? Sophia, do you happen to know?
The is 10.
Yes. It says 10 is. That's the number that goes with is. So right here at the top, I put 10. What is the next thing that I know in this problem? What's the next piece of information I know for sure in this problem? Dolan?
You know that 25 is going to be of.
Yeah. 25, it's not going to be the of. That's a good guess. But it's got the percent sign. Remember, so the anything with the percent sign is always going to go on top of that 100 on that other side. If it's got a percent, it goes there. And then, what is our of gonna be, you guys? That's a good hint. What is our of gonna be? Reading this problem, let's think. Sophia?
My voice is cracked, sorry. But I think the of is going to be the unknown number.
Yes. Because we see of what number? And what, if you watched that video yesterday, what is our vocabulary word for X? So what is our vocabulary word for X? So now here, we are math pirates. So we point our arrows towards them. We point our arrows towards them. Now I've got a question. There's two ways we can do this. In fact, this is the way that we're doing it. We're basically going to either single jump or double jump. There's two ways, but this is the best way to do it. Can I single jump this one, or do I have to double jump this one? What do I think? Can I single jump, double jump? On your fingers. 1 for single jump, 2 for double jump. 1 for single jump, 2 for double jump. Yes, my people who are participating, it is 2 for double jump. I can't get from 25 to 10 easily. I have to simplify this. I'm going to write it out as a ratio table because it makes it easier to see. We know we're doing a double jump, so I do my double lines. I have 10 over X equals 25 over 100. I need to find their greatest common factor. What is the greatest common factor between 10 and 25? What's the greatest common factor between 10 and 25? Greatest common factor between 10 and 25. Who would like to answer that for me? Delaney, yes?
5?
Yes, it is 5. Excellent. It is 5. How do I go from 25 to 5? How do I go from that, Dolan?
You multiply 5 times, my mind's blank, 2. No, not 2, 3, I'm sorry.
So, Vahe, what do I do to get from 25 to 5, Vahe?
How is it a 5? I just have a question.
Marley, what do I have to do?
Times it by 5.
Ooh, to get from 5 to 25, I multiply by 5. So the other way, I divide by 5. Perfect. And then to get from 5 to 10, what do I do to get from 5 to 10? I want to know. 5 to 10. Lucia. Multiply by 2. What we do to the top, we do to the bottom. So we're going to do the exact same thing here. Divide by 5 times 2. Who can tell me 100 divided by 5? 100 divided by 5. Lucas, what's 100 divided by 5? Sorry, I couldn't.
100 divided by 5 is 20.
Yes. And then, Amelia, what is 20 times 2?
40.
So I find out, if I bring this back here, 10 is 25% of 40. 10 is 25% of 40. Now there's one more way we can do this problem. Here I have this fraction, 25 over 100. I've told you guys that you need to memorize certain fractions, to make it decimals. If you need to memorize certain fractions to make it decimals. I want to get this in the most simplified form. So, what is the greatest common factor between these two, maybe? What's the greatest common factor between 25 and 100? What is that? Who can tell me? Ella, yes.
4?
Ooh, so she said the wrong answer, but I know exactly what she's saying. No, she was correct here because she said the wrong answer, but she's saying it backwards because everybody does it backwards. She says 4. She's correct in the sense that it's gonna be a 4 there. That's what we're doing. So we get from 100 to 4.
20.
Exactly. So 25. Funny enough, they are both divisible by 25. Think about it like quarters. Don't worry, I know exactly what you guys are saying when you say it backwards. I know exactly what you guys are saying. You gotta get a little careful when we say things because we want to make sure. Hey, 100 divided by 25 is 4. Just like our quarters. What's 25 divided by 25? Show me on your fingers, people. Show me on your fingers. Exactly. It's 1. So I could go and I could simplify the fraction first. And watch what happens when I simplify the fraction first. Now I simply have 10 over x is 1 over 4. Look at that. That's another way. We can either simplify the fraction first. Again, I point my arrows to my x because we're math pirates. 10 from 1 to 10 times 10. From 4, we do the same thing, times 10, and we get 40. Is that the same answer? Thumbs up, thumbs down. Is that the same answer? Yes. So there are many ways you can go about doing this problem. You can either simplify fractions first. You can figure out if you need to double jump or single jump. There are many, many different ways. In fact, the last way, which is the hardest way, and I don't advise, is that you could do this. And we do our butterfly math, and we need to make them equal. Now I just have a question, because if you watched the video yesterday, you will know what this is. If you watched the video yesterday, you will know what this is. Ready? What is 25 times x? Who can tell me what is 25 times x? Dolan?
25 times the unknown number.
Yes, she did say it in an English sentence, which I love. She said 25 times the unknown number. I love it. How could I say it? Lucas, do you know?
I'm pretty sure it would be 25 for the numerator and x as the denominator.
Ooh, you're close. That's dividing, right? Because I just divided 25 by x. Ella, what do you think?
I'm just taking a guess.
Take a guess. I love it.
Sure. But I know 25.
Then what is it?
The same thing, I forgot what his name was, what he said before, except the numbers are swapped.
So you think it's going to be x over 25?
Yes.
Almost. That's still dividing. We have this word times. That means multiply. Vahe?
25 times blank.
25 times blank. That's the same thing. You want to know what it is, you guys? Pearson, I'm going to give you the last guess. Pearson, do you know?
We're about to say,
Yeah? What is it? Well,
25 over x.
ooh, 25 over x. We're so close. That's a division. Are you ready? Are you guys ready to go? Oh my God. Are you ready for this? Are you ready for this? 25 times x is 25x.
Oh.
Yeah, you see this? What there is that we don't see is we don't see this little multiplication sign in the middle. And the reason we don't see multiplication sign in the middle is because when numbers and letters, when anything is touching like that, it means multiply. When anything is touching like that, it means multiply. Let's look at this again. What is 7 times star? Who would like to answer 7 times star for me? Let's see, Lucas, yes?
It is 7 with a star next to it.
Perfect. 7 with a star. 7 star. That's it. What if I asked you, what is 13 times heart? What is 13 times heart, Dolan?
13 heart.
13 heart. That's it. When we're multiplying by an unknown, you just put that letter next to the number. There's nothing else we can do just yet. You just put that letter next to the number. We don't know anything else. We don't know anything else. So there are several ways that we can do this problem. There are several ways. The other way is to multiply it like this, or we could simplify it first, which makes our lives much easier. We do all of that. Watch this. Here's the other way, like I was just showing you. I had 10 over x equals 25 over 100. Who remembers what we simplified 25 over 100 to? What did we simplify it to, Pearson? Yeah. So we simplified it to 1/4, 1 over 4. This is the last method that I was just showing you. We're going to butterfly math this. 1 times x. It could be 1x, but we don't write ones. We don't care. It's just x. 4 times 10 is 40. We want them to be equal. That means x is 40, right? That means x is 40. What if I did it with the 25s? Are you ready? This is going to sound unreasonable, but watch when I do it with the 25s. Because we always want to simplify first. If I did it with the 25s, I would find out it's going to be 25x is going to be equal to 1,000. I got 25x equal to 1,000. Now I'm going to do something I said in the last video. I'm going to isolate my variable. Isolate. Who can tell me really quickly, what do you think the word isolate means? What do you think the word isolate or isolation? Lucas?
I think isolate, I think it's going to mean, like, you don't use it until the very end.
Ooh, I like that idea. Don't use it until the very end. Marley, what do you think? What's your hand up?
Like,
For isolate, what does isolate mean?
like 0 or like 1.
Ooh, so like kind of like 1. We're getting kind of close. Vahe, what do you think?
Like quarantine, basically.
Like quarantine, basically. And when you're quarantined, you are all by yourself, right? You're with your family, but you're all by yourself. You're alone. Isolate means get it alone. Isolate means get it alone. I want to get x by itself. I need x equals. What's in the way of x equals? What's happening here again, you guys? What is that sentence saying? What's my numerical sentence? Who can tell me the numerical sentence that's happening here? What is it, Ella?
25 times x equals
Perfect.
100.
Oops, it's supposed to be 1,000. But yes, 25 times x equals, that was my bad. 25 times x.
Question.
So I need to simplify. I need to get this. What am I going to do to get this? I need to get x equals. This is 25 times x. I want to get rid of that 25. If this is 25 times x, what can I do to get rid of 25 times? 25 times something. What can I do to get rid of 25 times something? Dolan?
You can get rid of the dot standing at.
I can't get rid of the dot. But what do I want to do to get rid of that 25? If it's being multiplied, let's do the opposite. Sophia?
Multiply by 0.
Should multiply by 0. We're kind of close. What we're going to do is divide by 25. What is 25 over 25 equal to? On your fingers, 25 over 25 is equal to 1. So that goes away. I don't need to write 1x. That's just x. And then as a side note, if we decided to divide, we would get 40. There you go. Several different ways to do the same problem. Do the one that's easiest for you. Let's look at this one. Synthwave music makes up 75% of Miss Diaz's music library. If she has 90 synthwave songs, how many are in the music library? We don't see is over of here, but we do see parts over whole. First of all, what's going to go on this side? What's going to go on that side? Lucas?
I was gonna say 75% over 100.
He is 100% correct. We know that that's percent over 100. We add our percent here, and it is always over 100. What is the part and what is the whole? Do I have the part or do I have the whole? The other number I have here is 90. Is that going to be the part of my music library or the whole of my music library? Marley. So she says the whole. Do we have anything that, Ella, what do you think?
I think it's gonna be the half.
She thinks it's going to be the part. So we see this. What do you think? I'm going to take one more because we want to have a tiebreaker. Vahe, what do you think? Part or whole?
Part.
It is the part because it's asking me there are 90 synthwave songs. 90 matches with 75%. Do I know what the whole is? No. So I'm going to put an X here. In this case, again, we would use our ratio table to double jump and or let's simplify this fraction. 75 over 100. This is one you need to know, one you have to have memorized. 75 over 100. Think about it in terms of money. Ben, when I simplify that, what do I get? Yeah, we get 3/4. 75 cents is 3/4. $1 is 4/4. So I don't even care about this one anymore. I'm done with it. I don't want it. I've now since simplified. Oops, that went away. 3/4. I can get from 3 to 90. So I'm going to do the same. 3 to 90 times 30. Because 3 to 9 is times 3. Put a 0 at the end. Times 30. Who would like to tell me what is 4 times 30 equal to? Can anybody tell me what is 4 times 30 equal to? Harley, what do you say?
160.
Ooh, not 160. We're so close, though. That would be times 40. Vahe, do you know?
120.
120, exactly. She did 4 times 40, which is, I see exactly what she did. 120. So there are 120 songs in my music library. Let's look at our is over of again. Let's match this. Where does my 30 go? I'm going to put different colors up here. I'm going to put the red. I've got orange. I've got green. And I've got blue. What's going to go in my red box? What's going in my red, technically, circle? What's going in my red circle, looking at this problem? Lucas.
30%.
Not 30%.
30, just
yeah,
30.
Just 30, exactly. What is going in my green one? Who can tell me in my green one? I'm going to call on Amelia, yes?
50.
50. Ella, what's going to go in my blue circle?
100.
Yes, always 100. Hey, and if I don't know, it's an X. And that's telling me the of what number. That's my of at the bottom. What means X? So I got to figure it out. The best way to do this is simplify fractions. One way to do it is just to cross off zeros. But who happens to know exactly what the most simplified version of 50 over 100 is? Amelia, what's 50 over 100?
1/2.
1/2. So that's the best way I can do that. 1/2. To get from 1 to 30 times 30 times 30. And I find out that my X is equal to 60. There we go. It's that easy. Part over whole and or is over of. I want you to try this one on your paper. So you're going to set it up and you're going to solve for me. So Ella, go ahead. Tell me.
Okay, so it's gonna be 20% over 100 for the second fraction, and then you're not sharing your screen. 60. an X.
Yes.
That's the answer.
Perfect. Hey, I don't even need to simplify, but if I did, who can tell me what 20 over 100 is simplified? 20 over 100 simplified. Amelia, do you happen to know what 20 over 100 is simplified?
1/5.
Yes, it just happens to be 1/5. Here it doesn't necessarily matter all that much because I can do this. 20 to 60 times 3. 100 to x times 3. Ella, what is x equal to?
X is equal to 300.
Whoop, whoop, 300, you guys. So, George spent 60% of his money buying a game statue. If the statue cost $300, how much money did he have? So again, this is going to be a part over whole. We know already the percent, 60 over 100. I just need to figure out my last number, 300. Is that the part or is that the whole? Think about that. Is that the part or is that the whole? Ella?
It's the whole.
300, she says that's the whole. It's actually, Marley, what do you think?
The part.
It is the part because it's asking how much money he had. So it's asking what was the total amount of money he had. That's the thing that we have. So we got 300 over x. I don't need to simplify, but if I did, I would get 3/5. But 60 to 300. Who can tell me how I go from 60 to 300? How do I go from 60 to 300? Ben? Multiply by 5, yes. Hey, you guys, based on that, how much money did my husband have in total? That's George, that's my husband. How much money did he have in total? I'm going to answer it for us because we know. Well, actually, Marley, yes?
500.
500. $500. Again, we're going to set this up and do it together. 15 is our is. Then we've got 30% always over 100 over what number? 15 to 30. What do? It's smaller, so I'm going to divide. And show me on your fingers, what am I going to be dividing by? Since it's smaller, I'm going to be dividing. What am I going to be dividing by? Yes, we divide by 2. So we divide this by 2. Who can tell me what is 100 divided by 2, Marley?
50.
50. So I know that one went fast, but we're going to look at this next one, okay? Because it's just placing points. What number is going to go here? And when I say number, it could also be an X. What's going to go here? Who can tell me what is going to go there? Who wants to tell me? Ella, do you know?
Yes, but I also have a question. I'll say it though really fast.
Say it first, and then...
Okay, so for the first one, it's going to be 220 for the first part, 25, sorry. And then for the next one, it's going to be 75% over 100 because, yeah.
Excellent. So we don't know our X goes at the bottom, especially because it says of what number. Remember, what means X. We went over that in the first thing. What means X. And then all we would need to do is find how to go from one to the other if we can. And we always need to know the most simplified form of our fractions. It's always helpful to know the most simplified form of our fractions. So, do you happen to know, does anybody happen to know how to get from 75 to 225? Does anybody happen to know? Amelia, do you know? Ella? 3 times. Again, if we don't know this, this is the stuff that I'm going fast with just because we can spend time on that later. 100 times 3 is 300. If you don't know how many times a number goes into another number, divide. Divide that number by that number, and then we find out how many times it goes in. So we find out 225 is 75% of 300. That's our is over of. We find out that 225 is 75% of 300. Again, I want us to look at this one. Who would like to set up the whole problem for me? Who would like to just set up and tell me where the pieces go? Lucas.
75 would be the part.
Perfect.
And right next to it, it would be 15% over 100.
Excellent. Perfect job, you guys, and I would put it in an X. Now, again, I actually can't go from 15 to 75. We might want to simplify this. We can simplify it, and then we would solve. I'm going to divide. Does anybody know the greatest common factor between 15 and 100? Can you show me on your fingers what the greatest common factor would be? Take a guess. Take a guess. What can I divide them both by? Yeah, I see it on some of our hands. We can divide them both by 5. 15 divided by 5 is 3. 100 divided by 5 is 20. 3 to 75. Can I go from 3 to 75? Yeah. I multiply it. How many quarters make up 75 cents, you guys? If I have 75 cents, how many quarters make up 75 cents? 3 quarters. Quarter is worth 25. I'd have to do 20 times 25. Again, I don't feel like doing this because I don't want to waste our time on that. But we get 500. I have a question for you guys before I take questions. Is X always going to be on the bottom of our first fraction? No. Sometimes, depending on the question, it might be here. Sometimes, even in the future, it might be here. The only place it cannot be is on our 100. The only place it cannot be is on our 100. That's it. It's the only place it cannot be. Here. I would like Amelia to set this up for me using our is over of equals percent over 100 method.
Okay, so, sorry. 36% over 100, and then,
which number is the is?
9.
Yep. And then what number is our what? Do we have it? Show me on your fingers. It's X. So exactly.
I have a question really quick.
Hey,
Yeah?
how do I get from 36 to 9?
And is sorry, it's
Camilla, yes?
You divide
Camilla is saying yep.
by 4.
Divide by 4. I do the same thing here. You should get good at dividing hundreds. We get 25 because there are 4 quarters in 100. So we find out 9 is 36% of 25. Here's a good one. Because I had Dolan ask that question. Dolan, where am I going to put the 7? Where am I going to put the 7?
We're gonna put 7 at the top.
Yes, Dolan, because it's the is. Do I have an of here? Do I know what my of is yet? Do I know? Not yet. It's unknown, so it's X because it says what? I get 70 over 100. This is easy one, you guys. This is easy. On your fingers, how do I get from 70 to 7? Yeah, we divide by 10. We divide by 10, and I find out X is 10. All of this is knowing that it is over of and or part over whole equals percent over 100. I know that sounds complicated, but it's really not. Let's do this one. 7 is 35% of what number? Kayla, set this one up for me.
So on top it would be 7 and X because it says what?
Perfect.
It would be 35% over.
You guys are nailing this. Like I said, I know I'm going fast. Class is ending. 35 to 7. I'm going to divide by 5. So I'm going to divide by 5. Who can tell me what 100 divided by 5 is? 100 divided by 5. If your hand's up, I think you know it. What do we think it is? Amelia?
20.
Yes! So 7 is 35% of 20. We look at here again. I just want to answer this question because it's a word problem. Before 1982, pennies were 95% zinc and 5% copper. If 100 pennies minted in 1980 have an approximate mass of 15 grams of copper, what is the total mass of 100 pennies? So I care about this. What is my percent here? What is the percent that I care about? Because it's asking a specific question. What is the percent that I care about? Who knows? Dolan, do you happen to know the percent I care about?
Yes, you care about 5%.
Yes, because it's asking about copper. Then it's saying if 100 pennies minted have an approximate mass of 15, then what is the total mass of 100, right? So we've got all of that. So I want to have, except this is a little weird. I actually don't like this problem and we don't have time for it, but I'll go back to it later. In the guided practice, it's the same thing. 40 is our is. 20% always over 100. What? That's all you need to know. If you can do is over of, if you can do part over whole, then you can do this lesson. 20 to 40 times 2 times 2, 200. But I also want you to make sure you know the simplified versions. That's 1/5. All you do is long divide. Here, who would like to set this problem up for me? Just set the problem up for me. Who would like to? Michaela.
So it would be 90 over x, and then it would be 25 over 1.
Excellent. This one I would need to double jump because we can't go from 25 to 90, so we need to simplify it. Again, I don't feel like doing that right now. Same thing here. Who would like to set up this problem for me, just so we can see this in the guided practice? Who could set up this problem for me? Lucas.
120 will be the part, and next to it will be 30% over 100.
Excellent, and that's our unknown. This one I can do easily. Times 4, times 4. If you don't know this, just practice. 400. So 120 is 30% of 400. Who would like to set up this problem right here? Vahe, can you set this one up for me really quick?
60 over x.
Perfect.
15 over 100.
Excellent. I can also do this one really quick. Anybody on your fingers, do you know how to get from 15 to 60? On your fingers, do you know how to get from 15 to 60? Ella, what do you think? Oh, well, hold on. We got it. Some people on their fingers said times 4, so we get 400. In the first year of ownership, a new car can lose 20% of its value. If a car lost 4,200 of its value in the first year, how much did the car originally cost? So we're asking how much the car originally cost, you guys. Do you think that's the part or the whole? Eden, what is it?
So it's the total of what the car cost.
Exactly. So this is our total. So that's the total. So when I set this problem up, it says how much. How is again our question word, meaning X. That's our whole. X goes down here. It lost that much money. And we know it's 20% over 100. We know it's 20% over 100. Because I'm lazy to get to here, we multiply it by 210. So I'm going to do the exact same here to the bottom. I'm going to multiply 100 times 210. And I get the total price of my car to be $21,000. $21,000. So your homework for tonight is going to be page 159, numbers 1 through 6. And I also suggest trying numbers 7, 8, and 9 because the more you try, the better. Just make sure you remember, is over of equals percent over 100. And or is over of means part over whole. I know that. Thank you guys.